You can steal it. Or if you really want to make sure that people scan it, what you do is you say something like, this is to enter, especially for students, this is to enter a drawing to get out of one final exam of your choosing. Everybody will scan that, right? My idea is way better. Or tell them it takes you to a petition to get litter boxes installed in the bathrooms. Have you seen this stuff?
Yes.
Yeah, apparently there's a movement called is it the furries?
Yes. Oh no. Oh.
Where people identify as cats and dogs, and in the high schools they want litter boxes in the bathrooms. Yeah. And the thing is, I get it. I mean, people have all sorts of weird fetishes and stuff, but I'm not sure where at some point you're crossing the line when you're asking for a litter box in the high school bathrooms.
I don't want to walk. No. Not going there.
I don't know. I kind of do, just to say like that actually happens in real life, but yeah, real life has gotten pretty funny these last several years, like in a sad way, but like things that would have been on like Saturday Night Live 10 years ago are now just on the news. That's right. Also, like The Simpsons. The Simpsons has predicted all sorts of stuff. Like even this last week, they showed I guess 8-9 years ago, there was an episode of The Simpsons that predicted the Queen's death in 2022. And I think it had also predicted Trump as president years ago, and other things like that. Okay, so we were talking about types for variables, remembering memory stuff. So remember, way the human beings solve problems is memory, asking questions, repetition. 100% of programming languages have facilities for these three things. So what we're going to introduce first is we're going to learn how, effectively, I'm giving you a box of Legos. All right, so if I kind of talk about the cadence we're going to have over the next, well, really, it's going to be the next 3 semesters of programming, but certainly over the next several weeks in here, is I'm going to give you this box of Legos that has all the stuff in it that you need to build a certain thing. I'm going to give you a homework assignment, and I'm going to give you the Legos that you need to accomplish that. But then you're going to have to figure out how to put those Legos together to solve the problem. All right. So again, this goes right back to the idea that I promise all of you are good enough problem solvers to do this. And it's going to frustrate you when you're like, why is it taking me so long to do this homework and I just can't get it when this seems like such an easy problem? Okay. It's because you're not good at breaking problems down to those little tiny baby steps yet. All right. So be prepared to be frustrated when you do your homework. It's not that you're too stupid or you're falling behind to the rest of the class. 90% of the class is going to be in the same boat as you. Okay. A couple of you had some background or just really take to the stuff quickly, might be outliers, but in general, I'm going to hand you, here's some tools, and this is everything you need. Hopefully I give you everything you need to solve the problem, because sometimes that's fun when I leave one thing out and then, you guys don't ask questions between class and you all spend 19 hours in your homework and then come back and say, oh, well, you just needed to do. But I'm going to give you all the things you'll need to do the homework, and then you'll have to figure out how to put it all together. All right. So we're going to introduce these 3 features. I'm going to try to get through all of them today. So we won't actually need to get through all of them to do our first assignment, but I'm going to try to get through all of them today. All right. So reminder, C++ is a strongly typed programming language. And that means that when we create variables, when we want to remember something, we have to specify the kind of value we want to store inside that variable. All right. And last time we were talking about the various types. What are our options that we can put before those variables? Because the syntax here is the type followed by your variable name, followed by an equal sign, followed by the initial value. And then a majority of lines in modern programming languages like C++ end in a semicolon. Officially, we would say for the language that all single line statements end in a semicolon, but we're going to see some exceptions to that. But when in doubt, assume there's a semicolon. Well, no, that's probably bad advice, because there are times where a semicolon won't be wrong, but it's going to give you bad output. I'll try to give you examples of that. So let's not do a word of advice there. Just most times a semicolon is what ends a line. Sometimes when you have like loops and conditionals, that's not what actually finishes that structure. All right, so what are our options to put in this type portion when we're defining the kind of value we can store in a variable? And just to pop our code back up, I don't remember, did I save it last time? I don't remember if I saved it. Well, whatever, I'll just. So for instance, if I want to store an integer called age and set it equal to 18, this is my type, int. The name of my variable is age, and I'm going to start off equal to 18. I can create another variable, int weight. Let's go with 140, something like that. So I have two separate things I'm remembering here. One's called age, one's called weight. They're both integer types. All right, that's the kind of animal I can put in that bucket, which means I cannot come here and say weight is equal to 3.14. Okay, that would be an error, because I initially defined weight to hold an integer, and now I'm trying to put something in there that is not an integer type. It's a decimal type. Okay. We only define variables one time. So once I've defined this variable called weight, I can then change it later on like this, but I don't put int in front of it again. You bring it into existence one time by saying, here's the kind of thing it's going to hold, here's its name, here's its initial value, and then later on I can vary that value, hence the name variables. I can vary that value to whatever I want, as long as it's within a legal type that will fit in there. Okay, that makes some sense. And again, this stuff is going to come with practice. So really, when I'm asking you to, when I say, does it make sense? I'm asking you, does it academically make sense? Not, are you going to be good at it yet? Okay, I promise you, you're going to make mistakes. All right. So here are our possible types. Now, the reality is we would call these actually primitive types. Primitive types are variable types built into the language that are only capable of holding a value, as opposed to object types, which we're going to learn later on in the semester, which some of which are built into the language, and then we can also invent our own object types. Object types can hold 0 or more values, but they can also do other stuff. Okay, but our primitive type values, these are things given to us as part of the core programming language, and all they know how to do is hold a value. All right, they can't do extra magic tricks. All right, so we talked last time that we have a whole bunch of different ways of holding signed whole integers, right? So signed means holds positive and negative values. We have a way of holding 8-bit sign, 16-bit sign, 32-bit sign, 64-bit signs. Realistically today, you will basically never use a short. There isn't like a good reason. We talked last time that the reason we have so many different ways of holding whole numbers is because memory used to be really, really, really expensive and also very limited. We didn't have tons of memory. So as a computer programmer, we had to be careful about what footprint we took up when we built a variable. Today, we have tons of memory, so we don't really need to worry about that. So there really isn't a good use for a short. 16-bit values are not special in any other way. And since we're not really caring about how much space we take up in memory, you'll never use a short, I bet you, in your entire career, unless you're modifying somebody else's code from 20 years ago. Bytes actually are still commonly used in some network programming type stuff, video streaming, things like that, because when you're receiving stuff over a network connection, it's coming in streaming as byte by byte by byte by byte. It has nothing to do with the fact that we're only wanting to take up 8 bits of space. It has more to do with that's the format that I'm getting this stuff in. So I need a bite-sized bucket to grab the video as it's coming in. Okay, it just happens to be the right tool for the job. A majority of the time when you're writing code, high majority, high 90s, you're going to use integers when you need to hold a whole number. And if an integer isn't quite big enough, you'll use a long. Okay, so these are going to be common. Int is going to be all over the place. You're going to be using ints all over the place. All right, so whenever you need to hold a whole integer, you're going to throw in an int. Now you could go old school and say, well, I'm going to be really careful about the memory I use, and I'm going to use the correct type of integer type. That's fine. You can do that. It's not wrong, but it wouldn't be common programming practice today. Go ahead.
Usually just leave that to the compiler.
That's kind of the thing is one of the jobs of a compiler is to make, let's call it a mediocre programmer look like a better programmer. So our compilers today, they analyze your code. We have multi-pass compilers today. They analyze your code, and we'll talk more about that when we get into functions and stuff, because that'll give me an opportunity to talk about single pass versus 2-pass versus multi-pass compilers. But the compilers have evolved a lot over the years, and they've gotten very, very, very good at looking at your high-level code and making some, figuring out maybe if there's enough information there, how big of a value you ever store in here. And therefore it will only, under the hood, use the correct processor's hardware register that doesn't hold 64 bits of data, but instead holds 16 or something like that. Okay, but the point is as a programmer, you don't really need to worry about that today because we have lots of memory. It's still important that you understand it, because if any of you go and become like C programmers writing stuff for embedded systems, like you're creating software for like dishwashers, stuff like that, where they aren't dealing with a modern laptop or a modern tower computer. Instead, they're this little tiny microprocessor that's a computer on a chip, and you might only be dealing with 32 kilobytes of memory. Then it does become important if you're working with like embedded systems. I would say don't think about that at this point, because we want to keep things as generic as possible. Right now, we're thinking about telling a general purpose computer what to do, and these guys today have plenty of memory for us. So we don't need to concern ourselves with that level of detail, but we do want to appreciate why we have so many different integer types. Okay. We also talked about chars last time, with the idea that the char type is actually in C and C++, it's an 8-bit unsigned value. In Java, C#, Swift, it's a 16-bit unsigned integer, and that's because it holds numbers that map to characters on either the ASCII or the Unicode character set. All right, in C and C++, it's the ASCII character set. So there's an original ASCII, there's 128 unique symbols. In extended ASCII, there's 256 unique symbols. And an 8-bit unsigned value gives us 0 to 255. Okay. And again, this kind of goes back to what we had talked about when we were looking at number conversion stuff. We talked about like different bases. And I asked kind of what is a number? A number is a way of representing something else. A lot of times we use numbers to represent, for instance, if I say a car is going 70 miles an hour, it's representing speed, the kind of the magnitude of the speed. If somebody gives you their weight, their age, the number they give you is relative to something. When we say we're going to use a byte, yes, it holds the number between 0 and 255. But the reality is what it's doing is it's holding a value that corresponds to something on that ASCII character chart. You know, like the value 16 isn't any better than the value 34 when we're talking about ASCII values. It just happens to correspond to a different thing. So when we're talking about chars, the magnitude of the value really isn't important. Bigger values are not more important than smaller values or vice versa. It just happens to map to a certain thing. So we're using that char type to just hold a number that maps to something else. So it really is data representation. All right, but we don't need negative numbers in chars because the ASCII set starts at a 0 and goes to a 255. And so if it starts at a 0 and goes to a 255, we don't need a -4 because there's nothing on the chart that's a -4. That's why it is unsigned. So we get that extra bit back, which means we don't have, because we don't need to represent positives or negatives. We just assume everything's positive, and that gives us more space to hold value. All right, so questions about any of that? Okay, so the next two are floats and doubles. You can think of a float as kind of like an int, but for floating point numbers with decimal points in them. And a double is kind of like a long. So a float is a 32-bit followed by a dot, followed by 16 bits, signed decimal, let's call it signed floating point value. A double is 64 bits, followed by a dot, followed by 32 bits, signed floating point value. And depending on the language you're working with, these things here might change a little bit. You don't need to memorize this. Effectively, what we're saying is a float holds up to 32 bits worth of data for the magnitude. So it can hold that negative plus or minus 2.1 billion, similar to an int. Go ahead. Like if I rate the number 3.14, yeah, I understand. That's the dot. In the number 3.114? Right, yeah, I'm breaking it down here. So before that decimal point is that number of bits, after it is this number of bits. And this isn't something you have to memorize. It's more just appreciating that a float is kind of like an int. It can hold 32-bit values before the decimal point, and then after the decimal point, you lose a little bit of precision compared to the double. Doubles can hold 64-bit values before the decimal point. So it's kind of like comparing an int is like a float, a long is like a double, but for decimal point values. Now, what's interesting about that is the go-to move in most modern programming is to use double as the default. So even though int is our go-to for integer whole numbers, and then we only use longs if an int wasn't big enough, for floating point values, doubles tend to be the default. You'll use a double, and actually to differentiate between doubles and floats in a programming language, you usually have to do something special to tell it. You have to put an F at the end of it to tell it it's a floating point value. So really, whenever you create decimal values, so if I want to come back in here and I want to say, I want to create a variable for pi, I would say double, let's call it a variable pi, and this is 3.14159, whatever, something like that. Okay. Questions about that? Okay. So let's do a couple of things here. So we talked last time about printing some stuff out. We use the cout function to print some stuff out. So cout, and then we have these little arrows where we put in what do we want to print out here. So I'm going to go ahead and I'm going to print out H. Now in the next line, I'll do the endl thing too. That just kicks it down a line afterwards. All right. Now I'm going to print out age. I'll put it in parentheses just to specify age. We're going to say divided by 4. So 18, which is the current value of age. So when it's doing this math here, age is going to resolve to its current value. And age currently holds an 18. So what's 18 divided by 4? 18 divided by 4 is 4.5. All right. So you might expect this to give you a 4.5, but it's not. It's going to print out a 4. So there's my original value of age, 18. And then when I take age and divide it by 4, I get a 4 instead of a 4.5. Age has not changed. If I wanted age to change, so if I print out age again here, you're going to see it's still an 18. If I wanted to change permanently, I would have to say something like age is equal to whatever age currently is equal to divided by 4, something like that. And that would then change age moving forward from that point on. I started it off as this value. I printed out the original value. Then I modified the value of age to be equal to a new value. All right, make some sense? All right, so let's just go back to what I had here before. And we saw that since in this case, I did not change the value of age is still equal to 18. But let's focus on this whole why is age divided by 4 a 4 instead of a 4.5. So 18 divided by 4 equals 4. Why not 4.5? This is called integer division or long division from 3rd grade. All right. And we've already done some of this math, right? When we did one of our patterns for number conversion to go from a decimal point value to any other base, we divided over and over again, storing the quotient and storing the remainder, right? So 18 divided by 4 is actually 4 remainder 2, right? Or if we're doing it in decimal math, it's 4.5. So if I get the 4 here by taking age and dividing it by 4, how do I get that remainder 2? We have a operator here, percent symbol. There's my 2. So we're going to say 18 divided by 4 equals 4. 18 mod, this is the modulus operator, 4 is equal to 2. This is 4 remainder 2. So this operator right here, so we'll say percent is the modulus operator that gives us the remainder from an integer division. All right, make sense? Now, if I had made age a double, so if I just change the kind of value I wanted to treat age as, now we get our 4.5. C++, strongly typed language. So it requires me to advertise the kind of value I'm putting inside of a variable. Well, since I've said age holds a double, and I put 18 in there, it's going to store it as 18.0. But then when I go and do math with it, it's going to treat it as a floating point number. And that's when I get my 4.5. Sometimes that's what you want, right? Sometimes you want it to do, let's call it normal math. You know, if I divided 18 by 4, as human beings, we tend to think of that as 4.5, right? It's been a while since we really cared about some of that remainder stuff. Now we're coming back, and I'm telling you, actually, some of that remainder stuff is actually pretty important in computer science. It's not better or worse, it's just sometimes the right tool for the job. All right, so we understand how to do integer division versus floating point division. One's not better or worse than the other. Right tool for the job whenever you need it. Your first homework assignment will certainly benefit from the remainder portion of things. Okay, so hint, hint, hint. Okay. So, let's see, you're gonna need that. All right, so let's introduce a couple other things. Do you need anything else to solve the first homework problem? I'm still going to go on with more stuff. I just want to put the assignment up before I go any more. So, no, I think that'll be enough to do the first one.
It's funny, you just leave out one thing.
Yeah.
It's not uncommon, but if I ever do it, I did it on purpose. Well, that's why we have the Slack channel that I encourage you to use and put a question up there. I'll put this up on Blackboard. All right, so what we're going to do here is we're going to make change. Pretty simple, simple thing. If you go in, not that we use cash anymore, but if you go into the store and you buy a pack of gum and you give them a $5 bill, and the pack of gum was I don't know, 72 cents, you know, they're going to give you change back for what's left, right? So they are going to give you change in terms of, let's just say, dollars, quarters, dimes, nickels, and pennies. All right, not that we want to carry around chunks of metal anymore, but it's still a thing. Okay, so define a variable that holds the cost of an item. Define another variable that holds the amount of money given for that item in terms of pennies. So we're going to pretend like you pay for everything in pennies, I guess. Your program should display to the screen the change that should be given to you in the most efficient manner in terms of dollars, quarters, dimes, nickels, and pennies. So if we were looking at an example here, you know, if we had a cost that was, I don't know, what did I say, 72 cents? And, oh yeah, we'll just say we paid 500 cents for this. Really, it's 500, or paid with a $5 bill. We would take 500 minus 72. So change owed is 428 cents. And we're going to give that to them in terms of $4, 1 quarter, 0 dimes, 0 nickels, 3 pennies. That's the output of our program. How many dollars, quarters, dimes, nickels, and pennies should be given to you to be the most efficient change based on it? Make sense? And this can be done all with just variables using that integer division thing we just talked about. Okay, go ahead. It's going to be the same, but C, you could just assume everything's in C++ in here. That's what we've been working with, is that is a template, but it'll be identical. Everything I've shown you so far is the same, except printing stuff out. In C, it's printf, and C++, it's C out. Other than that, all the syntax is the same. And you can actually use printf in C++ if you want, if you import standard io.h instead of iostream. All right. And I always, I'll just throw this other thing out as a blanket comment. When I give you homework, I want you to solve it in terms of the stuff we've introduced in class. I give you the things that we've done in class and the assignments. I give it to you in that, and purposefully in that manner. Often when we come into class, we'll solve it the way I expected you to solve it. And then I might show you a better way to have solved it by introducing another tool to you. So even though you might be able to find that other tool out there, or if you're an experienced programmer, maybe you know of another tool, solve all the programs in terms of what we've done in class. So we'll even put that as a little statement here. Solve using only what we have learned in class. Right? It's not going to be impressive if you go and pull out some sort of magical. It's kind of one of the reasons why I don't use Python in the beginning class. Python has all sorts of little shortcuts for things where, yes, it works, but do you even know what it was really doing? Okay, we want you to practice this stuff and get used to that problem solving thing. All right, questions about that first programming assignment? Go ahead.
So you're gonna give us the numbers, like the cost of the object, and then.
You're going to give that to you. You're going to define a variable that holds the cost of the item. You might initially put 72 in there. You're going to define another variable that holds the amount of money given. You might put 500 in there. And then your program should spit out that stuff as the answer. So you're not taking any input in from the user yet. You're hard coding the input. You're defining two variables at the top and just saying, this is what it costs. This is how much the person gave me. Poof, this is the change. And then if you want to try it for a different amount, you just go and change the value of those couple of variables, run the program again, it'll give you different output. We're going to learn how to make these more generic. We'll learn how to take things in from the user, but for right now, let's practice just with this stuff. Good.
So basically, it's not like we have to make it so that whatever number, no matter what number you put in, it's just like we're programming it like that specific amount.
Well, no, I mean, if I went up here and I changed the 72 to 141 in my variables, and so if that's the only change I made in my program and I hit run again, it should give me different output here.
Okay.
Yeah. I'm just giving you an example here that if that first variable held a 72, and if your second variable held a 500, this is the change it should give you. Yeah, I mean, the point is I should be able to change it to any number. All right. Submit the self-assessment and a link to your code on online GDB. And you can get that link after you've written your code here. Just click on share. And it's going to give you a share code thing right here. That'll let me go and see your code. All right. Now, one thing I would encourage you to do, because especially as you keep building stuff up, create an account on online GDB. It's free. And save your files. So I'm going to go ahead and save this. It's going to ask me what's the name of my project. We're going to call this guy CSC200 let's say intro C++, something like that. So it's going to go ahead and save that file in there. So if I want to come back and open it back up and I have to rewrite this stuff each time, I can do that. All right. All right. Any other questions about the homework before I keep trucking? All right. So this might take you, I mean, when we write this in class on Tuesday, it's probably going to take, I don't know, 3 minutes to write. But I expect for many of you, it's going to take longer than that. Okay. But I promise you, I've given you everything you need to solve the problem. It's not a hard problem. Okay. Most of you in here could make change if we had this problem, but now you got to break it down into the small steps that a computer would require. All right, so we now know how to do variables. Now we need to learn how do we ask questions. Asking questions is done using this last type. We can create variables of type Boolean. Booleans hold true, false values. Okay, so something is either true or something is false. Under the hood, it is stored as 0 or 1. Actually, it's stored as 1 or 0 to be accurate for that. Again, computers like numbers, so it's still storing this as a number, but human beings, we're going to think of it as true and false, and modern C++ lets us put trues and falses in there. So I can say bool, let's say Sunny is equal to true. And then I can print out Sunny. All right, so notice here that it printed out that 1. It's actually storing it as a number, but as human beings, we think of it as that 1 or the 0. All right, make some sense? Go ahead.
So are we able to say if Sunny equals true, or do we have to say Sunny equals 1?
You would say equals true, and we're going to look at that here in a second.
Okay.
Yeah. Basically, I just wanted to show you this to show that under the hood, it is stored as a number. Once you get to like Java, we'll look at next semester, you can't find the number. You can't get down to have it reveal the number to you, even though I promise it's still being stored as a 0 or 1 under the hood. All right. So technically, in let's see if they actually, I think the latest version of C++, they block this, but technically, why can't I type here? This is just not a thing anymore. There we go. Technically, I should be able to do math with Booleans, even though that should not make sense. So there's your 6. Okay. That's kind of why in new languages, they say, look, when you create a variable to hold a Boolean, your intention is to be able to store trues and falses. Okay. Which allow us to ask questions like, if it's sunny outside, let's put on sunblock. All right. Make sense? The intention wouldn't be for us to create a variable of type Boolean and then start doing math with it. But technically we can't. Again, this is a reason why I like using C++ as the first language, because it lets you get away with murder. You shouldn't, but this is kind of the wild, wild west of programming. And I think I explained last time, I want you to appreciate some of the quality of life features that have been added to these new programming languages once we start learning them. We're dealing with stuff here from the late 1960s in terms of what it's doing for us. So it's making us learn the stuff. All right. But as long as we always pick variable types that are meaningful to what kind of value we're going to store in there, we won't have a problem. Just because I can do math with a Boolean doesn't mean I should ever do math with a Boolean. All right. Questions about that? Booleans hold trues and falses. They just happen to be represented as zeros and ones under the hood. Ones and zeros, one for true, 0 for false. Okay. So this Boolean thing here is going to be important. Yes, we can create variables like this of type Boolean, and every now and then you might. We'll have some examples in here, I'm sure, where we will create a variable. Maybe we create a variable called like flag or something like that, that as we're doing a bunch of mathy stuff, we set the flag to false if we run into something down here, so that later on we can say if flag is equal to false, do something different. But generally speaking, we use Booleans to create things called Boolean expressions. A Boolean expression is any expression that boils down to a single value of true or false. Okay. Now, this starts getting us into the territory of making sure that we look at code and try to ask ourselves, how will this resolve before we just make an assumption? You've already heard me do that a couple of times today, like when I said something like age is equal to age plus 4, something like that. When I see this single equal sign, that's the assignment operator. I am assigning whatever's on the right-hand side of this to the variable that's on the left-hand side. So age is going to get a new value here because we have the assignment operator. What value is it going to get? It's going to get whatever the current value of age is. So we need to resolve the current value of age. So what the computer is going to do behind the scenes here is it's going to turn age into the number 18. It's going to resolve that for me. And then 18 plus 4 is 22. That's the value that will ultimately end up in age after this line. All right, we want to get used to thinking through lines of code and resolving it in our head so we know what it's actually doing. If you find yourself when you're working on homework assignments, typing some stuff, getting a weird error. So here, I'll force an error here. I'll forget a semicolon at the end of the line. We'll go ahead and hit run. It's going to scream at me and it's going to say expected semicolon before C out. Now this one's a pretty straightforward one here where it kind of makes sense what's going on. It shows you what line number and everything it's on. But what's common for beginning programmers is as soon as they see an error, they don't actually read what the error says. They just run back up to their code and start changing stuff. So then what ends up happening is it becomes this trial and error thing until you technically get the right answer, but you have no idea why it worked. So my advice would be never run a program until you've made changes that you expect there to be a certain outcome. You might be wrong. That's part of the learning process. But make sure when you make a change, the change came from some informed decision, not just you're randomly changing stuff. If I force another error here, I'll remove that closing curly brace there. If I hit run, expected this guy at the end of the input. So, you know, some error messages are more cryptic than others. This one's not overly cryptic, but you will run into cryptic ones. Make sure you're reading them when they pop up. Debugging your code, because you will have errors, is a skill. All right. In fact, I promise you, you're going to have errors in your code for a while, and you're going to have more. In some cases, when you first start, you're going to have more errors than you have lines of code because you did something weird, or you know, whatever it is, you forgot the namespace thing. So if I come back in here, let's say I removed this this namespace thing. Now all of a sudden, all my uses of C out no longer work. So C out was not declared in this scope. Did you mean this guy? All right, so get used to reading the error messages. Boolean expressions. Any expression that boils down to a single value of true or false. Arithmetic, Boolean operators. Most of you already know these, or know most of them. Less than or equal to, greater than or equal to. Not equal to, that's probably going to be a new one for most of you. Exclamation point followed by the equal sign, no space. Equal to, double equal sign. Not to be confused with the assignment operator, single equal sign. Good. This one checks for equivalency. So for instance, 5 equal 2 would be false. 5 and 2 are different numbers. Right. 5 equals 2. We'll try to assign the value of 2 to 5, which isn't going to work either because 5 is a literal. We can't just redefine what the number 5 means in the world. But using this same example here, if I had a int a is equal to 5, then I said a equal. I guess it's I'm just gonna make this capital since it's gonna do it that way for me anyways. If a equal 2, this will boil down to false. A resolves to a 5. Is 5 equal to 2? It's not, so that's a false. As opposed to saying a equals 2. This guy changes the value of a to now to be 2. Good. Okay. If we put it in that context, we haven't looked at the if statement yet, but right now we're just looking at Boolean expressions. Things that boil down to single values are true or false. So as an example there, if I say 5 less than 2, that's a false statement. 5 is not a smaller number than 2. So this would boil down to false. 5 greater than 2 would boil down to true. So on and so forth. Okay. Most of these first ones are ones that, you know, you're already used to from math classes, that kind of stuff. Okay. So for beginning programmers, the real kicker tends to be with this double equal sign versus single equal sign in C-based languages. Double equal sign is the Boolean operator for equivalence. Single equal sign is the assignment operator that assigns the value that's on the right-hand side to the variable that's on the left-hand side. All right. So these are our arithmetic Boolean operators. We also have, I'm going to introduce the other operators, then we'll look at a bunch of examples. We also have things called logical Boolean operators. This is the AND operator. This is the OR operator. I'm actually just going to leave it at that for right now. Those are the two you'll use 99.9% of the time. So let's look at some Boolean expressions and see these in action. So example Boolean expressions. Remember, a Boolean expression is any expression that boils down to a single value of true or false. So you might have some expressions that look somewhat complex that ultimately, after you resolve them down, end up being a single value of true or false. And we'll show a couple of these here. So for example, if I have a couple of Boolean values here, so let's say Boolean A is equal to false, and I have int B is equal to 5, and I have int C is equal to 3. Let's go with something like that. All right. So now if I would say something like B greater than C, what's the result of B greater than C? And B is 5. So this boils down to 5. C is 3. Is 5 greater than 3? It is. So this would boil down to true. Therefore, is this a Boolean expression? Because this is a single value of true or false. Make sense? Okay. What if I say something like A equal false? That's true. A is equivalent to false. Also a Boolean expression. What if I say something like B greater than C? Actually, let's go this route. B less than C, or A equal false. So now this looks like a more complex type thing. We need to resolve it. Yeah. B less than C, what's B? B is a 5. C is a 3. Is 5 less than 3? It's not. So far we have a false. A equal false. You told me that's a true. So now we have false or true. For an or, this is true when at least one side is true. Is true when all sides are true, and false otherwise. So in this one, B less than C is false. A equals false is true. False or true. Well, since we're dealing with an or, if at least one of the sides is true, which in our case here it is, false or true, the whole thing ends up being true. Boolean expression. It's a single value of true or false. Is that a Boolean expression? What's the definition of a Boolean expression?
It gives off the boils down to
Any expression that boils down to a single value of true or false. This guy boils down to false. Is that a single value of true or false? Yep. We're going to see that in another example. Okay. That makes sense for Boolean expressions. So we use Boolean expressions to formulate questions. We're not going to just see these guys sitting out there in the wild very often. We could, but generally speaking, these are part of what we're going to use to ask questions. Getting back to how do human beings solve problems, we need to be able to ask questions. ask questions. I'm gonna say if statements. All right. So if statements, syntax is if open parenthesis, some Boolean expression, opening curly brace. Let's say some true statements. Then we could have optionally an else. False statements. And I would probably format this a little cleaner. Something like that. Where the else here is optional. You do not have to write an else with an if. So let's see this in action. So we're going to go ahead and we're going to say int age is equal to 15. All right. And we all know legal drinking age is 21, right? All right. So none of you are going to touch a drop of alcohol before you're 21. So we can ask a question. If age is greater than or equal to 21, see out, you can drink. Something like that. Go ahead. We've already seen that. That outputs stuff to the screen. Like we printed a hello world, it outputs hello world to the screen. Yeah, I mean, we've seen that a bunch of times. That guy would just write hello world to the screen. All right, so we are only going to output that line if this Boolean expression boils down to true. So right now, age is equal to 15. Is 15 greater than or equal to 21? It's not. So because that's false, we will not execute that code. That stuff will not occur because this was false. So the output of my program here is going to be nothing. All programs begin and end with main. So I start at main. Main here defines a variable, asks a question, and because my Boolean expression boiled down to false, I skip this and then main's over. If I change my age to 25, and that's the only thing I changed there, now it'll output you can drink. Make sense? And just a heads up, since it keeps happening to me, sometimes you might think your program didn't give you any output. I had to scroll to finally make it show up down there. I'm not sure why it does that, but you know, it's a thing. Oh, I guess it's because I had made this too small. Yeah, there we go. Now I can optionally put an else with this. I can say else wait a few years. So if I go back to a 15 now, where it used to not print out anything, now I ask the question, if this is true, do this. But now I've given it an alternative. If this is false, do this stuff down here. So now since age is 15, it's going to print out wait a few years. Because 15 is not greater than 21. So it skips this and it does this portion. If I change this to 25, Now it's going to say is 25 greater or equal to 21? Yes, it is. So it'll print out this and it will not do this. And we have the you can drink. Go ahead. All right, so I'm going to say yes. For some of you who've been who've programmed before, technically that is legal. You don't need to put the curly braces there. But I'm going to write something like this. What will the output of this program be? Won't be an error. But this is why you're going to always put the curly braces. The output of this program, 15, is 15 greater than or equal to 21? It's not, so this is false. Now, an if statement like this, it requires the body of it to be a statement. As I have it written here, the only statement that is part of that if statement is what I have highlighted. This woot part, it happens every time, regardless, because it's not part of that if statement. I've indented it so it looks like it's, you know, part of that if statement, but it's not. Woot will always happen. Now, if I wanted those two lines to be part of the if statement, which it looks like I did want that because I indented it to make it look pretty, that's when you'd want to always put the curly braces there. And now the woot is part of that if statement. Change this back to 25. Now it'll do both lines. So punchline is, while technically the curly braces are not required if you're only going to have a single statement following an if or an else, it's never going to be wrong to put the curly braces. And I think that it makes the code look cleaner by having your if statement begins here, it ends here. Gives you a nice, this is called a block statement. Because officially the syntax for an if statement is this guy here followed by anything that's a statement. This whole thing here is a single statement known as a block statement. A block statement is a collection of statements. If I only want to put one thing in my collection of statements, that's okay. I'm allowed to do that. If I want to put 500 things in my collection of statements, that's okay too. So you're never going to be wrong to have the opening and closing curly brace. So I teach it from the perspective that this opening curly brace is part of the syntax, even though technically it doesn't have to be. All right. So I'm not going to take off points if you write it correctly and don't use the curly braces, but I'll take off extra points if you try to take those shortcuts and then actually get the wrong output because you indented correctly, but the curly braces didn't match up to what your logic should have been. I would just say always use the curly braces. Along those lines, it's also why a language like Python is actually a pretty good language, because if any of you have ever programmed in Python, Python requires you to indent. So in Python, the example I had before, where those two lines were indented under the if statement, they would both belong to that if statement because it operates off of indentation here. Go ahead.
Basically every error I dealt with.
Yeah. And the reason why indentation is important, when we're coding, indenting is for human eyes, unless you're working with a language like Python that operates off of indentation. And what I mean by that is that is legal code. Wouldn't you agree that's harder to read right now? Okay. But it's still legal. Nothing prevents you from doing that in C, C++, Java, C#, any of those languages. As a computer programmer, you are responsible for making sure your code is readable, not just by the computer, but for the person who's going to be maintaining your code, the next person at work who's going to be picking up your project where you left off, that kind of stuff. Most of these interfaces, you've probably already seen it, like when I write an if statement here, so if, you know, blah, whatever, and I put that opening curly brace, when I press enter, it gives me the matching curly brace. So a lot of our modern editors for programming, integrated development environments, they have built in quality of life things that help you write better in, you know, better looking code. Okay. But if you're writing your code in some old text editor or something like that, it's not illegal to do so, but don't write your code like this. Indent. Things, when you have an opening curly brace, things should be indented underneath it. Right? Doesn't that look a lot cleaner? C++ doesn't care. In fact, we could put all this on one big long line as far as C++ is concerned. You don't even have to have it on separate lines. But that would be even harder for a human being to read, right? Yeah. Oh yeah. In fact, there's I don't know if they do it. I haven't heard about it in several years, but there used to be a competition of, you know, who could write the longest one-line program that did something. And as somebody wrote like a Pac-Man type thing in one line, and you know, it was unreadable. You know, but technically it worked. Go ahead. Mm-hmm. Yeah. But it's the same stuff. You could, those people wrote it this way and then just backspaced everything to get it all on one line. Because the compiler doesn't care, the computer doesn't care, human eyes care. So a language like Python that requires indentation, I actually like that feature of Python, because one thing that's common in beginning programmers, so listen carefully, is you don't indent. Make it a priority. Make your code look clean. In fact, that's all you're going to have going for you, for many of you initially, because you're going to have a lot of trouble getting your code to work. So it might as well be broken but look good. Go ahead. I've had to grade a lot of those. All the time. In fact, I think this guy even gives us a nice little button. I think I can click this beautify thing and it'll just fix it for me. Although I don't like this thing where it indented the curly braces under there, but that's still not horrible. I could live with that syntax if that's what it looked like. Oh, so now it actually just made my, oh, it didn't indent those guys a full tab. Whatever. Do it right the first time. All right. Questions about if statements with the optional else. All right. So whenever we want to ask a question, we would say, if something is true, do this. And the things that we have in here, we can have thousands of lines of code in here if we want. We can have other if statements in there. You know, we can say, if it's sunny, and then inside there, we might say, well, if it's cold, put a coat on. You know, we might ask multiple questions, just like we do in real life. This is how human beings solve problems. All right, go ahead.
Power switches, like statements, power switch,
well, what do you mean? What do you give me an example of when you say power? Like you talk about the button, the power button on a computer? When you say power switch, what are you talking about?
or the on the back is switching to the power.
Okay. Well, I mean, I guess you could think of that where you have a switch that either enable, I mean, a lot of times they have a switch that has which voltage you want it to run under, a 110 or a 220. So if you have it switched to 220 and you have it plugged into a 110, it won't turn on. So if switch A is in 220 position and input power is 110, don't fire. That kind of thing. So those would be, but we do that all the time, right? If coffee isn't too hot, take a drink. Okay, if coffee is boiling, maybe give it a moment. that kind of thing. All right. Again, we should run into, as you get better and better at solving these what seem like simple problems, you're going to see that what I've written here as how human beings solve problems is a truth. We remember crap all the time. We ask questions all the time. We do repetition all the time. We've just become so good at doing those things in our daily lives that we're not aware we're doing it. You know, as you're walking down the hall and you're bobbing and weaving out of people and missing walls and texting at the same time, you're not driving yourself nuts asking a question like, am I going to hit something? I'm going to hit something. I'm going to hit something. I'm going to hit something. But you know you're doing it, right? Okay, it's happening. You're just so good at solving that problem, you don't know it. That's the gap we need to close for programming. All right, I'll put that homework assignment up on Blackboard. It is due before class starts on Tuesday. I will, and the self-assessment template I'm talking about is over on the left side of Blackboard. It gives you the opportunity to tell me how long you spent on this assignment and stuff, because this one won't be too bad, I think, but sometimes you're going to spend 3-4 hours on a homework assignment and have very little to show me. So I want to give you some points for your effort. So that gives you the ability to tell me the story. All right. I'll see everybody on Tuesday.